In the following lessons, we'll set up Rust on our computers. Before we get there, I want to explain exactly what we're going to be installing, which is the Rust compiler. In order to understand what a compiler does, let's begin by talking about source code. Source code is the code that we developers write. If you're new to programming, the simple way to describe source code is a sequence of instructions that we'd like for the computer to execute. The Rust source code looks different from source code in a different language, like Python or Java, but it's all source code at the end of the day. It is code that is meant to be readable by humans, by developers. The problem is that the computer cannot understand the Rust source code itself. So that brings us to the compiler. The Rust compiler is a program, it's a piece of software that translates our source code into an executable program that the computer can understand and execute. That executable program is often called a binary or a binary executable, and the computer can understand the instructions in that binary. Now, I have the definition of compile on the left-hand side, and the computer science term derives from the regular definition, which is to produce something by assembling information collected from other sources. That's basically what the compiler is doing. It's assembling all of our source code together and using it as the basis to produce something else, in this case, the binary executable that the computer actually runs. So you can think of the compiler like a language translator, all right? Now that brings us to syntax. Syntax describes the characters or symbols that developers use to write source code. It can vary from programming language to programming language, but these are the words and constructs and symbols that we use to write code. Some of them are alphabetic characters, and others are symbols, like, for example, the comma or the semicolon or the exclamation mark, right? So syntax is simply describing that combination of characters that we use to write code. Now, programming languages are very strict, and Rust is among the strictest of them all. Every detail matters to the compiler because it needs to have the source code be valid and legitimate so that it can translate or transform or compile that source code correctly into the binary executable that the computer needs to run. I want to bring up some very common syntax mistakes that a lot of beginners make, and I want you to be mindful, if you're new to programming, to be careful in addressing a lot of these syntax things, right? So for example, case sensitivity is something that matters a lot in programming. Case sensitivity refers to the casing of characters. A capital letter in your source code is not equal to a lowercase letter. A capital letter Z, for example, is different from a lowercase letter z. Another example is spacing. Spaces matter. One space is not equal to two spaces or no spaces. Symbols matter. A semicolon is not equal to a comma. Line breaks matter. A line break is whenever you press the enter key to make the content continue on the next line. Those line breaks matter. Brackets matter. Parentheses matter. All of these symbols add up to the syntax of a programming language, and the compiler needs your syntax to be correct in order for it to be able to translate the instructions into the binary executable. Now, if you make some kind of error, it's not a problem. The compiler will identify the area of the code that it is unable to parse. So what I recommend you do as you proceed throughout the course is you follow the exact content that I have on the screen and make sure you copy everything, including the case sensitivity, the spacing, etc. And then make sure you have a working program and that you see the exact result that I see on my screen. Then I encourage you to play around and try different syntax options. Try experimenting with the code to get a different output. But make sure your first execution works as well, because that is the validation that you have written the correct syntax out. There's nothing wrong with making mistakes. There's nothing to be scared of. The compiler will tell you if it is unable to translate, but you have to get into the mindset of a programmer, which is being extra careful in paying attention to these small details that may otherwise not be pretty concerning. There's a lot of times when you're writing or explaining something to somebody else in text that you can get away with some of these differences or variations. Programming is a lot stricter, and the compiler will hold you responsible. So make sure you are paying attention to your syntax. All right. This next sequence of videos focuses on installing Rust on macOS operating systems. So if you are a Windows user, you can feel free to skip these lessons. There is a separate batch of setup videos for Windows immediately afterwards. Before we install Rust for us Mac users, we need to get acquainted with a program that is already installed called the terminal. The terminal, which you can see right here, is what's called a command line interface. It's a text prompt where you can enter text commands for the computer to execute. This is the way that users interacted with computers before the modern graphical interfaces that exist today. Despite the fact that it looks outdated, the terminal still has lots of value to offer to developers. It tends to be speedier and more efficient, and it also offers more room for customization. There's a lot more that you can express with a text command than you can with a mouse click. So first up, let me show you two different ways that you can access the terminal application. The first is to open up a Finder window, this thing right here, and then on the left-hand side, you'll see an Applications folder. Within all of your computer's installed applications, if you scroll down, you're going to see a Utilities folder. And if I click into Utilities, in here, you'll find the terminal application. This should be installed on all Mac computers out of the box. I recommend dragging this application to your dock just so you have quick access. So that is the first option. The second is to use the Mac's Spotlight search feature. So if you hold the Command key and press spacebar, that is going to bring up Spotlight Search, which allows you to search for installed applications. So here I can search for terminal, and that should locate that application, press enter, and that's going to launch you into the terminal. You can close this application the usual way by either clicking the red X at the top or by using the keyboard shortcut Command+Q. So I'll close right here and then immediately reopen by searching for terminal, and there you have it. There are only a few commands that we need to familiarize ourselves with to work well with the terminal for this course. Your terminal works just like the Finder graphical application. So it is always located within a given directory or folder on your computer. So in order to access files, folders, and applications, you need to navigate around your file system, around your hard drive. But again, in here, we're going to be using text commands in order to accomplish that. So the first command I want to introduce you to is pwd. This is short for Print Working Directory. The word print means to output to the screen, and the working directory is the current folder that the terminal is in. So I type out the command, then I press the Enter key to execute it, and the output tells us that we are in the users/Boris folder. You're likely going to be in a different directory because you have a different username, and that's totally fine. This is where we are on the file system, what folder we are within. Now, how can we find out everything that is stored within this current directory? For that, there is a command called ls. ls is short for list. So what it does is it lists all of the files and folders within the current directory. So for me, these are all the files and folders within the Boris directory. All right, so we can see where we are, and then we can see everything that is within that folder. Finally, one more command is cd. We use the cd command to navigate into a directory. CD is short for change directory. So we use cd followed by a space and then the directory name that I want to go into. For example, you can see I have a documents folder listed right here. So I can write cd space documents, and notice that I am honoring the case sensitivity of the folder name. So we have a capital D here, so I'm writing it exactly as it is here. cd change directory into documents, press enter, and now we have navigated into that folder. So I can execute pwd again, and now you can see we are within that nested folder. If you want to progress upwards into the parent folder, if you want to navigate one level up instead of down, you write cd once again and a space, but instead of a folder, you provide 2 dots. So cd 2 dots means go up one folder. So this will take us out of documents back into Boris in my case. I can prove this with pwd. You can see we're now back where we started from. Another really helpful feature in the terminal is auto completion, and we do that with the tab key. For example, if I write cd, then I write doc, which is the beginning of documents, the terminal can figure out that we want to go into the documents folder because it is the only one that begins with this collection of characters, with this prefix. So if I write out those characters, then I press the tab key, the terminal will auto-complete the folder or file name. And this can be really helpful because, number one, it speeds things up, but number two, it also removes the opportunity for error, because if you're typing it manually, you have the potential to have a typo. Now, because it is auto-completed, we can guarantee that we have the right folder. Once again, once we are within a folder, we can use ls to see the contents. In this case, I have various files within my documents folder, and then using other applications that are going to be installed in the terminal, such as our Rust compiler, we're going to be able to use those applications, those programs directly within the terminal and supply various files to them for them to run their application logic on. All right. So at a very high level, this is a quick introduction to the terminal. You really only need to know a couple of these commands to be effective. So let's start with pwd to print the current working directory, ls to see the contents of the current folder, and then cd to navigate downwards and upwards across your directories.
Thanks for watching the video till the end. Please leave your thoughts below so we can discuss more about the topic. If you'd like to suggest a video that could help the community, feel free to message me on X or Instagram. We also share short videos on Instagram, so make sure to follow us there. Feel free to reach out. We'd love to hear from you, and might even create a video based on your suggestion. Thanks again for being part of our community. See you in the next video.